Yeah, it's my pleasure here to walk you through some of the learnings we've really kind of had over the last year or so that we've been working with some reasonably big customers on multi-tenancy solutions on their GPU environments. And especially with the advent of neoclouds, NCP customers, large GPU cloud providers, some of these questions have become kind of really important, and we've been working with them through some of the options and solutions there, and I want to walk you through what we've seen there. In particular, I'll briefly go over what multi-tenancy really means. We'll briefly talk about typical solutions there, and we'll talk about the trade-offs and what that means for then the different implementations. I'll give you a few examples of solutions that we've found to be very interesting for some really large cloud providers, and also how we integrate storage into the multi-tenancy, and I'll close off with some of the challenges and learnings in the end. What does multi-tenancy really mean? Everyone has kind of a slightly different interpretation of that, but it really comes down to you can have multiple users, for example, within the same team, which belong to the same organization. They might be collaboratively running workloads, and they might have workloads which need to communicate with each other. And that's, I think, a very typical setup as we are used to it in classic HPC batch systems, as they're deployed very widely, obviously, at the universities, for example, and in the supercomputing centers. But then you might have customers, or you might have organizations who want to group teams together. So a team could become its own tenant. Or if you think about being a cloud provider, you really want to have your customers as separate tenants who then can do within their tenancy kind of almost whatever they want, but who are very, very well shielded from everyone else. And the real challenge comes down to what are the best options to implement that? And of course, there's a kind of a variety of them. The typical solutions are, in the very simplest case, to just have dedicated hardware for your different tenants. And we see this, of course, with large customers who say, I've got these requirements, I need these many thousands of GPUs. They go to a partner who then implements the hardware infrastructure for them, and they get that whole implementation, that whole tenancy, maybe a whole data hall or a data center full of equipment just to themselves. That makes it really easy. In other cases, you do want to have multiple customers in the same environment. They might want to have access to compute and storage, but you want to separate them on a network level. So that's another way kind of to separate your tenants. If you really want to completely share your environment, as it was just discussed in the Nectar environment, for example, you can of course deploy a virtualization solution. And so then every user, every customer, every tenant can spin up their own virtual machines. They belong to them. You can have a completely virtualized network environment as well, which completely isolates those tenants from each other. And therefore you have kind of these secure tenancies which cannot interact with each other and are shielded from each other. And of course, typical implementations are there based on VMware, on Xen with Citrix, or the successor projects like XEPNG, or KVM-based solutions like OpenStack, again, like the Nectar implementation, OpenNebula, Proxmox, and others, which are, of course, now becoming quite popular with some of the challenges around VMware. Another option, of course, is to say, well, I'm going to implement the multi-tenancy based on containers to have essentially different users be able to run different containers on a Kubernetes environment, for example. Docker and Docker Swarm, of course, are some of the underlying container management solutions, which are options there as well. And some of you might have previously used Apache Mesos, which is now a retired project. The real challenge comes though in with the different trade-offs you have to make when you have to choose one of these solutions. There are, of course, questions around hardware management and utilization. And just in the previous talk, there was the question, what if I want kind of multiple machines with multiple GPUs each? How do I get a tenancy for that? Or what if I want just a single GPU which is part of a machine that has 8 GPUs, for example, in it. How can I define a tenant just with 1 GPU? Which goes all the way down to, I want actually just a fraction of a GPU. And in principle, there are solutions available for all of those. But that's exactly what you need to consider, how you actually want to design your solution and what you want to offer to your customers. It also has an important impact, of course, on the utilization of the system. If your granularity is very, very fine, that you can even make fractions of a GPU available, that means you can probably push your utilization of your systems very far, but you have pretty high overhead in actually managing that and the software stack that's required. In the simpler case, when you say my granularity is based on a single machine with 8 GPUs, then you'll have a challenge when a customer comes along and says, well, I really have right now only need for 1 GPU, I don't want to pay for 8. So those are the trade-offs that need to be considered. With that, of course, come then questions around the scheduling, fairness, and how to ensure quality of service. How do you then manage that cluster and that environment and the whole software stack behind it? How do you manage the security questions around it, which we'll get to in a little bit more in a second. Of course, then with security come questions around the operating system management, the updates, who is responsible for that? And again, depending on how you deploy your stack and how you architect your solution, that might be either the responsibility of the customer, if it's, for example, fully virtualized, or it might actually be the responsibility of the platform provider. If you provide the images for the users, then you have to worry about the security around the operating system as well. And then, of course, there are considerations around performance of bare metal performance, if you have direct access to the machines and the hardware, versus the overhead that comes with some of the abstractions like virtualization. Thanks to, of course, hardware support for virtualization, they're usually not very small, but that's something that still people consider. And in the end, of course, also then application management. How do you enable your users then to run applications? Again, are they just responsible themselves for deploying them, or do you make full application stacks available? Again, as the Nectar team just described, how they're making full workflows available to their users. And with that come questions around dependencies, software supply chain, software asset management, and security again. So if we then try to think about what does it mean that if you want to implement these different solutions and how can we categorize them? And one typical way to look at this, or typical nomenclature that's used, is where people say, we talk about hard or soft multi-tenancy. I think it's a little bit more nuanced than that. There is really a whole spectrum of solutions in between. And so if you look on the bottom, the hard solutions there are really around physical hardware and cluster separation, right? In the simplest case, when you just have separate infrastructure for separate tenants. We can do network isolation, we can do hardware-based virtualization, we can go then to logical network isolation with virtual networks, network policies, and node isolation as it's typically done in Kubernetes environments, which then also involves, of course, namespaces to isolate different groups, and of course then containers, which are kind of an OS-level virtualization, you could call it. Then you need to can go to, well, maybe I just want to do control plane isolation. Of course, you then can have also just different users and groups, where we now get to the very soft tenancy as we have it in typical HPC environments. Of course, different processes controlled by the operating system. You can separate workflows, or in the end, you can say, I really just make an application available where the application then manages the different users, the different customers, kind of the different tenants. So then the system is become of one coherent system again, and all of that might be then just be controlled at the application level. Of course, you can have also overlapping implementations there, and so for us, it's really kind of a continuous slider here from hard to soft, and it's really a question of which requirements do you need to meet and which features are you therefore going to implement. In particular, when we look at network multi-tenancy, and again, working with some pretty large GPU cloud providers, they are, of course, looking more on the harder side, where they really want to make sure that they separate their tenants from each other. So at the network level, what are our options there? And I want to dig into that a little bit more. So on the Ethernet side, which is, of course, used for high-speed RoCE, RDMA networks, for example, and of course also out-of-band networks, as well as access networks, we usually have the options of either just manually configuring the network and the switches, just with standard VLANs. That's fine. We can do manual configuration using EVPN VXLANs. We can semi-automate that with Ansible. And of course, we can also then go to fully automated solutions, which I'll get through in a second. On the InfiniBand side, if you have environments where you have both, then of course you can do that there also with partition keys to separate your tenants from each other. For the manual configuration, right, not going really through the process, but you can do all that, in the end, that's really painful. And it becomes even more painful if you have to make configuration changes very often. If you are a little bit more advanced and you use configuration management tools like Ansible, you can automate a lot of these processes, but that's still quite painful, and painful really means in the end it's brittle as well. So let's try to avoid that. So what are the options that we've been looking at, and some of the solutions we're working with? Netris, of course, Kubernetes, Rafe, which is really nice wrapper around Kubernetes, Arna, and there is a variety of others which we can chat about later as well. So looking at the Netris solution, which is really giving us the ability to fully automate the multi-tenancy configuration of the typical networks we have in GPU cloud environments nowadays. So when you look at your GPU hosts here, we usually have a east-west compute network for RDMA, either based on NVIDIA Spectrum X or InfiniBand or other solutions. And we have usually a tenant access network, a no-stuff network, usually also based on Spectrum with Cumulus running on the switches or something similar. And the nice thing is that with the Netris solution, we have essentially a controller which now takes over the management of all our switches and can implement now a VXLAN, the EVPN-based solution for multi-tenancy, completely in software configured through Netris. And the elegance of that is that now I don't have to worry about configuring all the switches manually one by one. I don't have to configure VLANs or VXLAN configurations by hand. I can do that through what is essentially a software-defined network environment with a control plane through Netris. And it's also connecting through, of course, BCM, UFM integrations, NetQ integrations, and NVIDIA Air integrations where I can simulate all the networks before I deploy anything. And that's a quite elegant solution as we've found. Because when you look at a kind of typical network here with lots and lots of GPU machines in the middle with typically now 8 network links each, it's really, really painful if you had to configure the network here manually for all these links and all these leaf-spine full-cloth switches. And that's not only on one network for east-west, you also have to worry about the out-of-band network, for example. And on top of that, if you have an InfiniBand network, that as well. So that makes it really challenging. And Netris is a nice solution to fully automate that. If you then go one step beyond that and you want to provide a Kubernetes-based environment, one solution that we've been working with is coming from Rafe, which is essentially sitting as an orchestration layer in between your hardware on the bottom and your tenants on the top. And with Rafe, you essentially have a completely automated solution to configure tenants now in a Kubernetes-based environment. And the most elegant solutions we have really seen is then a combination of the hard tenancy based on Netris on the network, which completely isolates your tenants from each other, and Rafe then on top of it, where you can, if you want to, configure soft tenants within the hard tenants if that's something your customers want. And so that's very powerful together. Because Rafe then also takes care of machine learning pipelines, Jupyter notebooks, for example, all the kind of application deployment on the top, as well as the user management, finance, dashboards, billing, and all the other things, which really kind of become the fully integrated solutions for GPU cloud providers and similar environments. And yeah, probably going just quickly through that again. Rafa, you have east-west networks there, north-south access networks. And with Rafa, you can also then implement Kubernetes features like vCluster, for example, where you can spin up virtual machines within Kubernetes environments. And you can also take advantage of Kata containers, for example, where each container can actually have its own kernel as well. So these are really interesting features which give us a lot of flexibility. And finally, getting kind of to the end, talking about the storage integration, which is an interesting challenge in itself as well. And in the following talks, we'll then dig a little bit more into modern storage architectures. So Ben's going to take care of that, and Malcolm afterwards will talk also a little bit more about the platform engineering aspects around some of these things. On the storage side, now you need to also consider that you probably don't have separate storage environments for your different tenants, but you have probably 1 or 2 or 3 large storage systems which you want to share among the different tenants. And so there you need to then worry about integration with different identity providers. You need to worry about encryption keys, quotas, quality of service, and we're working with lots of different partners. I just have here 2 highlighted with solutions from VAS and solutions from DDN, which allow you to configure those tenants now and give them access to storage based on either IP address assignments, for example. There's different ways how to do that, or based on subnets and identifiers on cluster systems, for example, the way DDN is implementing that. Of course, there's lots of other solutions as well from other partners, and happy to chat about that afterwards. So with that, I'll wrap it up here. The conclusions are really for us that hard multi-tenancy is actually hard to implement. Soft multi-tenancy is still not easy. Let's say it's just less hard, right? Manual network configurations are possible, and we've done that with customers, and some of the experts who have done this are actually sitting here. So Ben, actually, who's going to present the next talk, has gone through that with some customers, but they become unsustainable very quickly, especially in cloud provider environments where you need to change your networks quite often when the tenants change. And the real problem is if you then want to switch to a network automation solution after you've done the manual setup, you essentially need to wipe your complete network. You need to bring everything down and start from scratch, which is also not a very good approach for cloud providers who don't want to have an outage on their entire system. So in the end, really hard versus soft multi-tenancy is a continuum of solutions. We need to carefully assess the requirements against this continuum. An important part is also to plan for future requirements, because we see more and more customers moving towards harder multi-tenancy requirements. They want to bring on other customers with special requirements who can't just be users on a batch system. They want to bring them on as separate tenants. One recommendation is definitely implement automation from the start. It will save you a lot of time and a lot of head and heartaches. And in the end, of course, pick the right solution, the partner for the implementation. We've done a lot of homework in that space, and happy to chat about this a lot more. With that, I'll wrap it up. Thank you for your time. Happy for questions now, or you can, of course, find us later at the booth as well. Thank you.
Thank you. I think we have time for a couple of quick questions. I have one. So when you talk about multi-tenants, how to ensure the secure multi-tenants?
Use the microphone.
I have one. So when you talk about the multiple tenants, how to ensure the secure multiple tenants without sacrificing power of HPC? Any high-level comments on this?
Right, and so that kind of goes back to the challenge, how do you pick the right solution for your specific requirements? And especially in cloud environments for cloud providers, they of course have very high security requirements because they essentially can't really trust anyone on their system. They have to assume that they need to completely isolate their users from each other, and that's where you might want to go to the lowest level of the tenants of the security that we've looked at, the hardest part of the multi-tenancy, which goes back to either virtualization solutions, as the hyperscalers of course are implementing it, or when you look at some of the neo-cloud providers, they are going to isolating their users and their tenants on the network, which is exactly what the Netris solution, for example, does with VXLAN EVPN separation of your different tenants. And of course, when you think about some of the largest AI companies on the planet, they just say, I want to have the whole cluster to myself and I don't want anyone else near me. So that's then kind of the ultimate implementation of that. But of course, if you have lots of small customers who, where you have a problem kind of with the granularity, then you often see cloud providers going to Kubernetes-based solutions where you can then split your systems and have smaller tenants with soft tenancies set up through Kubernetes or with vClusters implementations with Kata containers or technologies like that.